Okay, today's lecture is on confidence interval. For mu. So, quick reminder, what does mu stand for?
Population.
Some of the population.
Some of the population. Population mean?
It is the mean of the population. Okay, so we're doing a confidence interval for the mean of the population. In this particular section, what we're going to do it for is when sigma is known. Okay, so again, we're throwing out some statistics jargon here. What does sigma stand for? Standard deviation of the population. Okay, so these are both population things, which we call parameters, right? Confidence interval for the mean of the population when we know the standard deviation of the population. Okay?
This is 7.2?
7.1.
7.1?
Yeah. Okay, so the first thing that I want to discuss is what we mean by an interval. So we have two things really. We have what's called a point estimate, and we also have what is termed an interval estimate. Okay? A point estimate, an example would be, let's say I was really curious what the average number of units a student at Las Positas College is registered for. Okay? So that's the thing I'm studying, the average number of units a Las Positas College student is registered for. Well, if I didn't have access to every single student, what I could do is take a sample. So maybe I took a sample of 30, 35 students, and I wrote down the number of units each one of them is registered for. Okay? And then I take the average of that sample, and maybe that average came out to 12 units. Okay? So I would say, all right, based on that sample, we have this point estimate. 12 units from this sample, but what I was trying to do is make a guess at the average of the whole population. Okay? So that would be a point estimate. The difference with an interval estimate is we don't just say 12. Okay, what we do is we say, all right, we're going to create this interval, and maybe it's like 10.5 to 13 or something like that. Okay? So we have a lower bound and we have a higher bound, and this creates what we call an interval estimate. All right, so maybe I should do 10.5 to 13.5. All right, so where these numbers come from is based on a very specific formula that we're going to put on the board and discuss. And your whole goal for this section is to just utilize the formula and come up with this interval, which is approximating some population thing that we're studying. Okay, and in particular in this section, you're going to have statistics from a sample, and you're going to use that to estimate the population mean. Okay, we're going to say, okay, with 99% confidence, or with 95% confidence, or with some level of confidence, we think the real population mean is in this interval. Okay? All right, so before we can do that, there's a couple of things that we need to look at. So whenever we do a confidence interval, there's going to be some sort of level. A lot of popular levels are 99% confidence, 95% confidence, 90% confidence. These are all ones that come up all the time, but you could do whatever you want. It could be an 88% confidence, or 92%, or 75%, okay? But these tend to be the most three popular ones. All right? Okay, so we have this thing called Z sub alpha over 2, right? And what you need to know about Z sub alpha over 2 is, first of all, it's just a Z value. Okay, so it's a Z value that we've been studying all along. And this alpha over 2 is going to represent where that Z value is based on a specific area. Okay? So if I take the first one, if I take a 99% confidence interval, you're going to have a normal distribution. You're going to have z sub alpha over 2 right here, and negative z sub alpha over 2 right here. Okay? And we have some shaded region in the tail. If we're doing a 99% confidence interval, then this middle portion represents 0.99. Okay? Well, if that is 0.99 and the whole thing adds up to 1, then what is left total?
105 each side?
0.01.
So 0.01 is left total area, right? So 0.01 for this and this, so that would mean that both of these would have to be 0.005. Does everybody see that? Okay, and there's a couple of important things that we want to know. Number one is alpha is the total shaded area. Okay, so please put that in your notes. Alpha is always representative of the total shaded area. So if I'm doing a 99% confidence interval, then what is alpha? It's 0.01, the total shaded area. Why are these both called alpha over 2 then? Because we're splitting it perfectly in half, right? We have half of it here and half of it here. That's why those are called alpha over 2. Okay? So alpha represents the total shaded region, and then we're splitting it in half, putting half of it here and half of it here because of symmetry. Okay? All right, so my question to you is, can you tell me what these z-values are? And the answer should be yes. I just have to go to my normal distribution table and I have to figure this out, okay? This is where we're working backwards again, all right? So I'm trying to find the z-value that corresponds with 0.005 area. So let's look at the negative z side, and let's see if we can find the closest thing we can to 0.005. Is 0.005 in there? Okay, so do you guys see where we have 0.0051, which is really, really close, and then right next to it we have 0.049, right? Which one's closer? They're both equally split in the middle, right? So in a rare instance when that happens, when it's right in between, then we're actually going to go right in between, okay? So if you look at this mark, it's at negative 2.57 and negative 2.58. Those would be the z-values that correspond to 0.051 and 0.049, okay? So what we're going to do is use negative 2.575 as my z-value. So this would be negative 2.575, and because of symmetry, this would be positive 2.575. Okay? So again, if you look in your table that we have with our book, if you look at negative 2.57 and then look at negative 2.58, this area is right in between. So we're going to use 2.575. Okay? Okay, so we have negative 2.575 and our z sub alpha over 2 at 2.575, positive on the right side. Okay, that's it. Let's do a couple more just to get used to how this works. Let's do 95% confidence interval. All right? So the directions would be something simple like find z sub alpha over 2 for a 95% confidence level. CL, confidence level. Okay? The way you attack this, it's always the same. If they want 95%, you're going to draw a standard normal graph. You're going to put 95% in the middle this time. So that area is 0.95. Okay? So what is alpha in this problem? What does alpha always represent? The total shaded area. What would that have to be?
Okay.
0.05, right? 0.05 for this to add up to 1. Okay? So if the whole area is 0.05, then what are each of these going to be? 0.025. Okay? It's always the same. 0.05 is left for the total area. I split it into half. This is going to be z sub alpha over 2. This is going to be negative z sub alpha over 2. They're going to be the same numbers, but one's negative and one's positive because of symmetry. Okay? All right, if I go into my book and I'm trying to find the z-value that marks area of 0.025, you go into the area portion of your z-chart and you try to find the closest thing you can to 0.025. Okay? So look in there and see if you can find the closest thing you can to 0.025. And you should get pretty lucky on this one. Why?
Exactly.
Because it's exactly in there. And what z-value gives you 0.025?
-2 or 1.96.
It should be negative 1.96. The z-value negative 1.96 gives you 0.025. Okay? So just double check that you see that that happens at negative 1.96. All right? Then by symmetry, this is positive 1.96. Okay? So to answer this question, find the z sub alpha over 2 value for a 95% confidence level. The answer would be positive 1.96. Okay, is everybody comfortable with that? So draw the area, the confidence level goes in the middle, whatever's left goes in the tails.
So
Question?
What does CL stand for?
Oh, confidence level.
Okay.
you don't include the negative 1.96 in your answer?
Well, usually when they ask you just to find z sub alpha over 2, they're specifically talking about the positive one.
Okay.
But you need both, the negative and the positive. Okay? And you'll see when we do the formula. Let's put the formula on the board, and then we'll see how to solve it. Okay, so you're going to have several confidence intervals. So you really need to be specific on which ones we're doing. Okay, so the first one I'm going to give you, this is a confidence interval, CI, confidence interval for the mean, when sigma is unknown. I'm sorry, when sigma is known. The next formula will be when sigma is unknown. Sigma is known. Okay, because we're going to have a different formula. Okay, so this is what it looks like. It's x bar minus z sub alpha over 2 times sigma divided by square root of n, big comma, then x bar plus z sub alpha over 2 times sigma divided by square root of n. Okay, that's my formula. Now, once you get the formula written down, there's a couple of things that I want to point out. And that is, first, x bar minus z sub alpha over 2 times sigma divided by square root of n. And then over here, it's the exact same formula, right? Except instead of a minus, we have a plus. It's x bar plus z sub alpha over 2 times sigma divided by square root of n. Okay? So in terms of getting this problem finished, all you really need to do are get these 4 numbers. That's one number, that's one number, that's one number, and that's one number. So if I can identify those 4 values, put them in the formula with a minus, put them in the formula with a plus, that will give you your interval. Okay? All right, let's do an example. A study wishes to estimate the average GPA of all students on a campus. Okay? So here we are studying the average GPA of all students on campus. That's what we're studying. Great. What are we given? From past studies, the standard deviation is known to be 0.18. Okay? So from past studies, the standard deviation is known to be 1.8. Okay. A sample of 58 students are selected, and the mean is found to be 2.23. So we have a sample of 58. they had a mean of 2.23. And the question says, find the 90% confidence interval. Find the 90% confidence interval for the true population mean. Okay? This is a very typical problem in finding a confidence interval for the mean. So what are we studying? The average, which is the mean GPA of all students. From past studies, the standard deviation is known to be 1.8. A sample of 58 students had a mean of 2.23. Find the 90% confidence interval for the true population mean. Okay? So the question is, do we know sigma, first of all? In this problem, does it say, hey, sigma is equal to 1.8? Does it actually say that? No, but it says from past studies, the standard deviation is known to be 1.8, okay? So is that coming from the sample, or is that coming from something else? It's coming from something else, right? So this is assumed to be the population standard deviation. Does that, everyone see that? Versus if I wrote a sample of 58 had a mean of 2.2 with 3 with a standard deviation of 1.8, that would say that it's coming from the sample, and that's a different problem, okay? So in this one, they are telling us that sigma is 1.8. What does 2.23 represent in this problem? That mean from the sample, which we call what? X bar, right? Or sample mean, yes. What does 58 represent in this problem? Sample size, which we call n. Great. We have 3 of the 4 numbers done, right? We have n, we have x bar, we have sigma. And then I need to do z sub alpha over 2 for a 90% confidence interval, which we have not done yet. Okay, we did 99 and 95, so now we need to go to the side of the paper and do a z sub alpha over 2 for a 90% confidence interval. Once I have that number, then I'm ready to go and just plug it into the formula. Okay? Okay, so quickly, let's go over to the side of the paper. Let's do z sub alpha over 2 for a 90% confidence interval. So if 0.90 is in the middle, what is alpha equal to? Alpha would be 0.10, right? Because the whole thing adds up to 1, so what would be in both tails, we would have 0.05. Remember, alpha stands for the total area of the tails. Alpha over 2 would be 0.05. So this would represent z sub alpha over 2. This would represent negative z sub alpha over 2. I need you guys to go to your chart and find the z value that gives me an area to the left of 0.05. And that will tell me what z sub alpha over 2 has to be. Okay? So you're looking in the area. You're looking for the closest thing you can to 0.05. Is 0.5 in there?
No.
What's the closest you can get to 0.5?
0.0505.
Right, and what's right to the right of that?
0.0495.
Which one's closer?
The same.
Again, it's right in the middle, right? So this has happened twice now. So I want right in between 1.64 and I want right in between 1.65. That's going to happen at 1.645, okay? So z sub alpha over 2 is going to be 1.645. And on the negative side, it would be negative 1.645. Okay? The good news, though, guys, is once you've done these, you can just write it down and remember it. So 90%, 1.645. 99%, whatever it was, okay? 98%, whatever ones you do, just write them down, because they're not going to change. Okay? All right, great. Let's do this problem. So the formula is 2.23, which is x bar. So I'll just come over here. 2.23 minus z sub alpha over 2, 1.645, times sigma, which is 1.8, divided by the square root of 58. Okay? That will be my left, or my lower bound for the interval. And then I'm going to put a comma right here and get the upper bound, the same exact numbers with a plus sign. Okay? Go to your calculators. And let's go ahead and go out 4 decimal places on both of these. Be careful with these fractions. So 2.23 minus 1.645 times 1.8 divided by square root of 58. I'm getting about 1.8412. So my left bound is 1.8412, comma. And then let's find the other side, 2.23 plus 1.645 times 1.8 divided by the square root of 58. And I'm getting 2.6188. 2.6188. Okay, sorry it's kind of messy, but did everybody get that? 1.8412, comma, 2.6188. Okay? Now, what did we do? Like, what does that even mean? What was the original problem that we were asked to find?
The average GPA, 90% confidence interval.
Yeah, so we're constructing a 90% confidence interval. So with 90% confidence, we're saying that the true population mean, so the true mean GPA of all students at this campus is between 1.8412 and 2.6188. Okay? Does that mean for sure the actual population mean is in this interval? No. Right? We're saying with 90% confidence. Okay? If we went to a 95% confidence or a 99% confidence, what's going to happen to this interval, do you think? To give us a better chance of having it in there, it should just widen. Is everybody with me on that? So if I go to a 99%, it's probably going to go a little bit more out on each side with a better chance of grabbing that actual population mean. Okay? Any questions on that? Yes?
Can you do a confidence interval of 100?
No. Right? Because then it won't work in the, like, when you, to do 100%, you won't be able to mark your z sub alpha over 2. But you could do like 99.9, which would be really good. Yes?
So are we going to have problems where, like, the standard deviation is, we have to figure out the standard deviation? Or?
You're going to have problems where the population standard deviation is not known, and so you're going to have to use the next formula, which we'll do.
Oh, okay.
Okay.
In that case, we're given the
Right, it'll come from the sample, which makes more sense, right? So let's think about this. We're doing a study about the population mean, but we have the population standard deviation. That kind of doesn't make sense, so that kind of is not going to happen, right? So usually what's going to happen is you'll have the mean and standard deviation from the sample, which will be a new confidence interval formula that you'll have to do. Okay? All right, any questions on this? And there's one more thing in this section that they'll ask you to do sometimes. So let's look at that. Okay, this is a formula for the minimum sample size needed. Okay, so minimum sample size needed for what we were looking at, an interval estimate of mu. Okay, let's take a look at what this formula looks like. It says n equals z sub alpha over 2 times sigma. That's a sigma, not a 6. Make that look a little bit better. Times sigma divided by e squared.
That's
Okay.
interval estimated of mu?
Yeah, an interval estimate of mu, yes. And then in this formula, if we come out with a decimal, put in your notes that you need to round that up to the next whole number, okay? Because we're talking about a sample size. So if you come out with any decimal at all, it's not going to make sense to have 17.2 people So I rounded up to 18 people. Okay? Okay, so we already know what n is, that's a sample size. We already know how to do z sub alpha over 2. We already know sigma, that's the population standard deviation. So this guy's new, this e. Okay, that e stands for error, and that's a level of accuracy that you want. Okay, and it should be pretty clear in the problem what the level of accuracy or error is. Okay, let's do an example. A researcher is interested in estimating the average salary of police officers. Okay, so we're talking about, in this problem, the average salary of police officers. Great. She wants to be 95% confident in the estimate. So she wants a 95% confidence level. Okay, and that's going to tell us what z sub alpha over 2 is going to have to be, right? The population standard deviation is known to be 1,050. So in the problem it says the population standard deviation is known to be 1,050. Then the question says, how large a sample is needed to be accurate within $200? Okay, how large a sample is needed to be accurate within $200? Okay, so I'm going to do this study about the average salary of police. She wants a 95% confidence level. She knows that the population standard deviation, it's 1,050. How large a sample must she take when she wants an accuracy or error within $200? Okay. All right, great. So I have all the things I need, and now we just plug in the formula, right? In this case, we're trying to find n, so it's n equals, okay, 95% confidence interval z sub alpha over 2. We just did that like 5 minutes ago, right? You have it in your notes.
1.96.
1.96. And again, once you've done it, you could always redo it, but you can start memorizing those as well. Times 1,050 divided by e 200. All raised to the second power. And whatever decimal we get, if we do get a decimal, we're just going to bump that up to the next one. So 1.96 times 1,050 divided by 200 squared. Okay, you get about 1.5.8841, right? So it actually comes out to 105.8841. But we're talking about how many people we need to have in our sample. So how many people do we need in our sample? 106. Okay. Bump it up to the next. Got it. Okay. So we did confidence interval for the mean, and we also did minimum sample size needed for the interval estimate of the mean. Okay. The formula we did today was when you know sigma. The next formula we're going to do is when you do not know sigma. Okay? And I'll just save that for the next lecture. Are there any questions on this one? Okay, good.